We are going to talk about target 1.6 in this video, which has to do with interpreting the multiple meanings of slope. All right, so let's get at it. Here is our application, our problem here. Okay, so I have a table, and the table below shows Martin's wages for his part-time job proofreading articles for his hometown newspaper. Okay, so it looks like given some hours, he's making some dollars. Okay. So I could label this X and Y if you want to, if that's helpful for you, all right? Because based on the number of hours, he's going to make some earnings, all right? So this is like my inputs or my X values. This is like my outputs or my Y values, okay? And I can see that over here on my graph too, because my first task is going to be to plot the data and then model it with a line. So I can see that my X values are my hours and my Y values my dollars. Okay, so let's go ahead and plot these points. So 230. Well, I got to think about my scale here, don't I? I think that I can just count by ones on the bottom. So this is 0, and I'm going to skip here. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, and then my Y values here. I'm going to scoot this guy up a little bit. Right, I need to get to 120, right? Let's see, if I do 0 and then 50, 100, 120, that'll work. So I'm going to count by tens. I'm just going to label it like this, though. 50 and then 100. All right, you can write these down in between if you want to as well, but I'm happy with that. So I'm going to graph here. So 230, so over 2 up 30, gives me that point there. 460. Over 4, up 60, puts me right there. 575, over 5, up, this would be 70, so 75 would be like about there. 690, 690 looks right there. And finally 8, 120. 8, here's 100, 110, 120. Right there. Okay, so there's my data plotted. I want to model it with a line. So I'm going to grab my line tool here, and I'm going to start right here at the origin, and I'm going to try to draw right, yeah, that looks pretty good, huh? Right through those dots, something like that. Okay, there we go. So it's plotted and modeled. Let's see what we need to do from there. All right, what is the slope or rate of change of the line? Okay, what is it? Let's go back and see. So my slope, well, it's tempting to say that it's up to, well, let's see, up 3 and over 2, right? It's a little tempting to say that, up 3 over 2. But we have to keep in mind that my scale here is counting by tens, right? So really this is increasing 30, and then this is indeed a value of 2, right? So I'm increasing 30, so up 30 over 2, rise 30, run of 2. Okay, so my slope or rate of change is 30 over 2. I do want to simplify that down if I can, so I'm going to do 15 over 1, or just 15 if you want to go like that. Okay, the meaning of the slope in the context of this scenario, what does that mean? 15 over 1 or 30 over 2. Well, let's go back and look at the graph. Well, I'm increasing $30. Okay, that's my Y value. And then I'm increasing 2 hours, right? So dollars over hours. And again, when you write out your slope, like if I erase this part right here, and I just leave 15 over 1, if you label this with the units, it often tells you pretty directly what the meaning is. So this was 15, let's go back here, dollars, and then over hours. So $15, 1 hour. Okay. So the meaning is $15 per hour. That's what it means in this case. Okay. Write the equation of the line that models this scenario. Okay, well, I need two things. I need the slope, which I just found, And then I also need my y-intercept, right? And in this case, it's just 0, which makes sense. Work 0 hours, make $0. Okay, so my intercept is actually 0. So I have a couple ways I could write this. Considering we want to do maybe y equals mx plus b, correct? Well, I have my m, right? That's my slope. So I'm going to plug that in there. And that was 15. And then I have my intercepts, right? And that was just 0. So I'll plug my 0 in there. All right, so 15x plus 0. Well, I don't need the plus 0, right? That doesn't do much. So I can kind of erase that. And this is good enough. That's a perfectly good model, right? My cost is equal to 15 times my number of hours. Y equals 15x. Okay, I'm going to use my graph for this next problem. It says to determine his wages for 10 hours of proofreading and explain what I did. So I need 10 hours. I'm going to go back to my graph. And here's my hours. Here's my 10. So I'm going to trace that up to my line. And it's right about there. Okay, so I could kind of count this out and estimate it a little bit, all right? I'm also going to use some things I know from back here that I'm increasing 3 for every 2 that I go over, right? So right here, I plotted that point, and if I increase 3 and go over 2, that's going to get me to here, right? So this is really like another 30. So either one of those kind of reasoning strategies gives me a value of 150 here for dollars, right? Okay, so I'm going to say my wages for 10 hours is $150. And there's my explanation, right? You can write that out. I just talked about it. In this case, I want to use my equation to determine his wages earned after 30 hours of work. Okay, well, I'm going to use my equation, right? And X is my number of hours, okay? Y is going to give me my cost. So I'm simply going to plug it in. I'm going to do some work over here. So I have some space. So Y equals 15X. Well, my X in this case is 30. So Y equals 15 times 30. Okay, so Y equals, and let's get a calculator, 15 times 30 is 450. All right, so 450. That's using my model, right? So wages, $450. There we go. Last question. How many hours must he work to earn $3,000? He needs to buy, all right, he wants to buy a new e-bike. Okay, well, I'm going to erase this work here, all right, and I'm going to use that space. All right, so in this case, I want $3,000 in earnings, right, or the amount he's going to make, $3,000. So that's my output value, right? So I'm going to use my model, Y equals 15X, okay? But my Y value is what I need to replace here this time, right? That I want to be 3,000. So 3,000 equals 15 times my number of hours. And this is what I'm trying to find, right? So I just have a simple one-step equation here. I'm going to divide both sides by 15 of this. Okay, so this cancels out. I get X equals, and this is going to be 200. I believe. There we go. All right, so 200 hours is what he would need to work to earn $3,000. Okay, and if you're not convinced of that, right, we plug it back in, and you can check your work, right? Y equals 15 times 200 hours. You should get a cost or an earnings of $3,000. All right, there you go. There's target 1.6.